For section 1.1, we're going to be looking at multiplying polynomials. Now, before we get to that, though, we're going to first start with combined like terms, or combining like terms. And we're going to really focus on multiplication here, but we want to make sure we're clear on addition whenever we have polynomials. So if I had something like x squared plus x squared, it's very important as we go forward today that we get the correct result of just something as basic as this. It's like saying I have 2x squared, so I'd say it's 2x squared. It is not x to the fourth. You're not going to change the exponents. That's something we did last chapter when we were multiplying them. Now, it's an addition, you're going to combine those two to get to that result. Now, it's not that we're not going to use multiplication at all. We'll get to that. But first, let's make sure we're clear on addition. So let's say I have 2x squared minus 4x plus 6. And I'm going to add to that x squared plus 5x minus 3. Now, these are both polynomials. Since they have three terms, we actually call them trinomials. So I have my first trinomial, second trinomial. In order to combine like terms, I'm going to add the terms that, like I said, are like. These are both x squareds. I have 2x squared and 1x squared, so that gives me 3x squared. I have a negative 4x and a 5x. That's going to give me 5 minus 4 is 1, so plus x. And then last, 6 and negative 3 comes out to be 3. So my result here is 3x squared plus x plus 3. Now let's take that exact same start we had, 2x squared minus 4x plus 6. And now we're going to do minus x squared plus 5x minus 3. Now before we get to that solving it, we can think of this as two ways. We're either distributing out the negative or it's just subtraction each way through. So it's 2x squared minus x squared. It's negative 4x minus 5x. And it's 6 minus a negative 3. So in this case, it comes out to be an x squared, 2x squared minus x squared is just 1, minus 9x, negative 4, negative 5, and then 6 minus negative 3 is like seeing 6 plus 3, so that is 9. So our result is x squared minus 9x plus 9. Now last thing we're going to look at is what if we went with 2x squared minus 4x plus 6 again, but now it's plus x cubed plus 2. Well, looking through it, I only have one term that's x cubed, so that's going to stay by itself. I only have one term that's x squared, so that's going to stay by itself. I have a negative 4x, that's by itself. And then the last one is 6 and 2, so it'll be 8. So it's not necessarily the position that it's in, it's their like terms or their exponents, that they're I should say the variables with the exponents that they have with them. Now, we have combining like terms aside. We can now look at going to multiplication. The first place we go with multiplication is the distributive property. Distributive property should not be something new to you. It's the idea if I said A times the quantity B plus C, we distribute A to both terms through multiplication and we get AB plus AC. But now let's give it some algebra values here. Let's go with 3 times x plus 6. If we look at this, we're going to multiply 3 to both terms. We get 3x plus 18. We could add a little bit more to that. What if we went x times x minus 2? Well, I'm going to multiply x times x, and we should know this from last unit. That's going to become x squared. And then x times negative 2 is negative 2x. We could maybe add a little bit more to it. 2x, x squared plus 4x minus 2. We're still distributing out the terms. My first term is going to be the 2x times x squared, which would be 2x cubed. 2x times 4x, is going to be 8x squared, and then 2x minus 2 is negative 4. So again, distributive property, multiply that term out in front to each term within the polynomial inside the parentheses. Now, what if we add a little bit more to it? What if it wasn't a single term times a polynomial, but we went and we did a polynomial times a polynomial with that same idea? So let's call this the binomial times a binomial. And all we're going to do here is we're going to keep that same idea we just had with distributive property. So I'm going to do x plus 3 times x plus 1. Now, in a minute ago, I said, okay, I would have taken x and multiplied it to those two terms. But now I'm kind of leaving the 3 alone. The 3 is also there, so why don't I multiply that to each of the terms in the other parentheses as well? So looking at the top ones, I have x times x gives me x squared. X times 1 gives me x. 3 times x gives me 3x. And 3 times 1 gives me 3. Now looking at what I have here, oh wait, I can combine some terms, x and 3x, and I get x squared plus 4x plus 3. So we multiplied x plus 3 times x plus 1 using that distributive property idea, multiplied everything from the first polynomial to everything in the second polynomial, and we had some like terms to combine. Now we're going to take another look at this, and again, this was distributive property. I want to show you, what if it was just, we'll use the called the area model, but we're going to call it the box method because it looks like a box. So I'm going to draw a box, and along each of the vertices, or each of the axes, we should say, each of the sides, I'm going to write x plus 3 here, and x plus 1. Now, to get a value within the box, you're going to multiply the two values that line up to it. So this first one is x times x, which gives me x squared. Top right, I get 3 times x, 3x. Bottom left, I have x times 1. And bottom right, it's going to be 3 times 1, which is 3. Now in doing so, when I write these out, it kind of looks very similar to what we had up here. But again, we can combine these two terms and get x squared plus 4x plus 3 as our final answer. In fact, this diagonal right here turned out to have the like terms that we could combine to get to our result. So x squared plus 4x plus 3. Now, you can use the distributive property idea. I'm going to work through and show you the box method just because as we're starting off, we want to make sure we're organized, keeping things in the right place, but we'll see some examples. And if you get better, you can always go back to that distributive model. So let's go something like x plus 2 squared. Well, that of course means I have x plus 2 times x plus 2. What you're not going to do is distribute that in and make it x squared plus 4. That's if it was multiplication and not addition inside, completely different. Don't do that. So I'm going to go x plus 2, x plus 2. So this box will be an x squared. Top right will be a 2x. Bottom left will be a 2x. And bottom right will be a 4. Now again, I have these like terms here, and I'm going to put this one as x squared plus 4x, that's the 2x plus 2x plus 4. Let's say now we went x minus 6 times x plus 6. So x minus 6, x plus 6. This term becomes x squared. Here I have negative 6x. Here I have 6x. And last, negative 6 and 6 is negative 36. Looking at like terms, both of our x's here, they actually become 0. So I'm left with x squared minus 36 as my product. Now, what if we wanted more than this? What if it wasn't just a binomial? What if we went to something like x squared plus 2, x cubed plus 2x plus 6? Well, using the distributive property, I could multiply everything in x of the x squared to these terms. I can multiply the 2 to all of these terms. The problem with that is I start getting a lot of terms. So let's do this. Let's go box method. I'm going to go x squared plus 2, then x cubed plus 2x plus 6. We've got to be careful when we multiply here that we're getting things in the right values. This box will be x squared and x cubed, which is like saying I have like bases, add the exponents, so that's x to the 5th. Down here, it's 2 times x to the 3rd, so that's 2x to the 3rd. Here I'm going to go the 2x, and the 2x squared is going to give me 2x to the 3rd. We'll go bottom middle. 2 times 2x is 4x. Top right is 6x squared. And the bottom value, 2 times 6, is 12. Now, I do have a set of like terms. That's the x cubes. But notice that the 4x and the 6x squared are not like terms, so I'm definitely not going to add them. So I write out what I have. I have x to the 5th. 2x cubed and 2x cubed is 4x cubed. Plus 6x squared. Plus 4x plus 12 gives me my result. But in this case, by multiplying a binomial by a trinomial, or 2 terms by 3 terms, I have this result. Now that's really endless. We could do any number of terms we would want. It would just make the box bigger, more values to go through, but it's a process we can repeat each time. Now the last one I'm going to show you before you're going to practice on a variety of these is what if we went with something like x plus 2 times x minus 1 times x plus 3. Now I have 3 binomials, and it's not that it's any different of a problem, it's just this time I'm going to work with these two, find an answer, and then work with that new answer and the x plus 3. So let's do that. Let's go with x plus 2 and x minus 1. So using our box, we go x plus 2, x minus 1, I get x squared, 2x, negative x, and negative 2. So I have x squared, like terms here, this just becomes plus x, minus 2. So now I take that original 3 terms, and what I'm saying here is x squared plus x minus 2 times x plus 3. So now I've used that part of it. I've now condensed it down to 2 terms. I'm going to multiply. Again, I'll just use box method here. And it does not matter which one is the row, which one is the column. I'm going to get x cubed, x squared, and negative 2x, working my way across, because I'm really multiplying the top values each by x. The bottom row is going to be 3x squared, 3x, and negative 6, because I'm multiplying this all by 3. My terms become x cubed. I have a x squared and a 3x squared, which is 4x squared. A 3x and a negative 2x, which is a plus x. My last term minus 6. So my result is x cubed plus 4x squared plus x minus 6. So now it's your turn. You're going to go through, you're going to work on combining like terms and multiplying and see how you do.